Good morning, students. Next, exercise 6.1, fourth sum. In this fourth sum, prove by vector method that the diagonal of a rhombus intersect each other at right angles. So, what is my rhombus? We know in rhombus all sides are equal. In rhombus all sides are equal. So, first we need to draw the rhombus ABCD. We will introduce a rhombus, nothing but ABCD. So, this is a rhombus. We introduce a rhombus diagram. We will name it as ABCD. This will take it as A. This is B. This is C, and this is D. So, we will draw one diagonal because they are speaking about a diagonal. They are speaking about diagonal. First, we know all sides are equal. All sides are equal. All sides are equal means the length are equal. Lengths are equal. The length is equal is nothing but magnitude. If I told length is nothing magnitude, for magnitude we need to put the modulus. So I am going to consider let A, B, C, D be a rhombus. Let A, B, C, D be a rhombus. We know in rhombus AB, we know in rhombus AB is equal to BC is equal to CD is equal to DA. This we know because rhombus all sides are equal general. But I am going to consider let AB vector is equal to A vector. AB vector is equal to A vector. But since length is same, but vector is going to be different. AB vector is equal to A vector, and BC vector is equal to B vector. BC vector is equal to B vector. So AB vector is equal to A vector, BC vector is equal to B vector. Now I am going to draw the diagram with using the arrow. This is called arrow. That is A, B, this moves C, this is going to move into D. So see, we know if I going to take this one is AB vector, this one is opposite, so I am going to take minus A vector. This is B vector, arrow is same, so I can take as a B vector. This is A vector, this I can take as A vector but opposite direction, so minus A vector. This is B vector, same direction, so I am going to take a B vector. So what I want to prove? This diagonals of a rhombus. I drawn one diagonal, so I need to draw another diagonal also. This is another diagonal. Diagonal of a rhombus. This is a diagonal of a rhombus intersect each other at right angles. This I need to make this diagonal and this diagonal were intersect at right angles. At right angles nothing but 90 degree. I need to prove 90 degree. 90 degree is nothing but perpendicular. What is perpendicular? I need to prove dot is equal to 0. To prove what I want to prove, diagonals of a rhombus each intersect each other at right angles. Nothing but AC vector dot BD vector. AC vector dot BD vector equal to 0, or AC vector is perpendicular to BD vector. If AC vector is perpendicular to BD vector, then I can say AC vector dot BD vector is equal. This one we need to prove because right angles something but perpendicular is 90 degree. 90 degree I need to prove dot vector dot is equal to 0. So I know what I know. This all sides are equal, so I can write modulus of A vector is equal to modulus of B vector. Since A vector is not equal to B vector, vector is not equal. Now also the same procedure, vector is not equal but length is equal. So to make a length I need to put modulus. Modulus of A vector is equal to modulus of B vector. I told the length is equal. I have told the length is equal. So modulus of A vector is equal to modulus of B vector. A vector is not equal to B vector. If I want length, modulus of A vector is equal to modulus of B vector. So I need to write AC vector. What is AC vector? This is a diagonal AC vector. This is the head, this is a tail. A vector plus B vector. A vector plus B vector, comma. Next I am going to see BD vector. BD vector is equal to, I can move on this side. What is this side? BD vector, this is head, this is tail. B vector minus A vector. B vector minus A vector. This is head, this is tail. Why is we should move like that? We can move this side. But if I am going to move this side, this is an opposite direction. I am moving in this direction, but this is opposite direction, so I can write minus A vector plus B vector, same only. If this is head, this is tail, B vector minus A vector. This is a one way I can move. Other way is, this is I am moving this direction, but this direction is opposite, so I want to write minus A vector and plus B vector. Minus A vector plus B vector. I can move in any direction, so I have written. So I want to show AC vector dot B vector. So AC vector dot BD vector is equal to this A vector plus B vector. I am going to write B vector plus A vector dot this BD vector, think about B vector minus A vector. You know what we know, B vector dot B vector is anyway B vector square minus, that is A plus B, A minus B, A vector square. You can write B vector modulus of B vector the whole square modulus of A vector the whole square. This I told you in previous class itself. Modulus of B vector, I can B vector square, I can write B vector square. Modulus of B vector square, I can write a B vector square. So you know length between these two are same. That is modulus of B is equal to modulus of A as a length. This is suppose it's going to 5, this is also 5. 5 the whole square, 5 the whole square, nothing but 0. AC vector dot BD vector is 0. Therefore, AC vector is perpendicular to BD vector. AC vector, AC is nothing perpendicular to BD. Therefore, what is the conclusion? Diagonal of a rhombus, diagonal of a rhombus intersect at each other at right angle. This is statement I need to prove. Hence proved. That's all the sum. So write the sum very carefully. But if I want to say the important one, this one you need to write. This one, this one, this one. If you write these all, you are going to get 3 marks from year to year. This one is enough and diagram is must. If you are going to write this one, you are going to get 3 marks. So be sure to get a 3 mark. Thank you.